This is an overview of the solution I came up with for problem 5 from the geometry round from the Stanford Math Tournament in 2022. So the question is, in quadrilateral ABCD, AB equals 20, BC equals 15, CD equals 7, DA equals 24, and AC equals 25. Let the midpoint of AC be M, and let AC and BD intersect at N. Find the length of MN. So I've drawn this quadrilateral here, and the first thing we notice is that since this diagonal of the quadrilateral AC is 25, we can see that this is a 7, 24, 25 triangle, and so this must be a right angle. And if we look at triangle ABC, we see that this is a 3, 4, 5 triangle with a ratio, common ratio of 5. So this is a right angle, and that's why I've already inscribed it in a circle, because we know that this is cyclic because these two angles add up to 180, and that means that these two angles must add up to 180 as well. And since we know that since this is a right angle of the circle, that means this must be like the diameter. Actually, not. Yeah, this is the right angle of the triangle, which means this must be the diameter of the circle, because we have two right triangles with the hypotenuse 25. So the radius must be 12.5. And we see that, so this is M, because this is just the midpoint of AC. And then if we draw this, the diagonals, where the diagonals intersect, this point is N. And we want to find the length of this. But we can't really, we don't really see anything at this point, but we can just use Ptolemy's inequality or theorem, which states that the product of the opposite sides plus the product of the other set of opposite sides is equal to the product of the diagonals when the quadrilateral is inscribed in a circle, or when it's the quadrilateral is cyclic. So we can just use that. So 7 times 20 is 140. And then 24 times 15 is 240 plus 120 is 360. And this is equal to one of the diagonals, which you already know is the diameter of the circle, which is 25, because that's already given to us. And then we can call the other diagonal, it's just dB. Solving for dB, well, we can just evaluate this left side first. We get 500 over 25 equals dB. And so we get dB is equal to 20. So we know that this length is now 20. And that means we can see directly that this is going to be, that triangle ABD is isosceles, because it's 20, 20, 24. So that means that we can just like draw this perpendicular here, and this must be a right angle. And what this tells us is that this segment, we'll call this, I guess, G. This segment BG lies on it passes through the center of the circle. Maybe it's not clear, I'll just make it like that. It passes through the center of the circle because this is perpendicular and this bisects it, so thus this must be part of a radius. And once we do that, we can kind of see that segment GB is parallel to segment DC, so this segment is parallel to this segment. And we can see that this creates like two similar triangles. DCN is similar to triangle NMB. With similar, and we can like also like find this segment GB, which is just since this is 12, this is 20, and with the scale common factor 4, so this is 5, 3, so this is a 3, 4, 5 triangle. So the total length of GB will be 16. But we only want to know if we know, but we know that MB is a radius because it passes through the center. So MB is 12.5. I'm gonna clear this up. Okay. And since MB is 12.5, and we know that DC is 7, we know that the similarity ratio between triangle DCN and triangle NMB is 7 over 12.5. And then we can just simplify this. 70 over 125. And this is just congruent to 14 over 25. So this is a similarity ratio between DCN and NMB. And why this is important is because we can just set the length we want, like MN, as X, and then we can, since this is the whole radius, this CN will be 12.5 minus X, because that's the radius, subtract that little length. And what this tells us is we can use this to set up a system of equations if we know the length of dn and nb separately, because we can just use the power of a point theorem, which states that cn times na is equal to dn times nb. So we can use that. And the reason why we need to know this similarity ratio, 14 over 25, is so that because we know this whole length db is 20, so then we know that dn must be 14 over 25 plus 14, because this is the similarity ratio is like this to this, and so if it's this to the whole thing, then this to the similarity ratio plus this part. So it's just going to be 14 over 39. So basically dn is equal to 14/39 of 20, because that's a whole length of db. Clear this up. Yeah, so that means that this should be 280 over 39 is the length of dn. And then the length of nb similarly must be 25 over 39 of 20. And this is just equal to 500 over 39. And so we have the separate lengths for both dn and nb, and we can just now use the power of a point theorem. So we know that cn, because we're looking at these two chords, TB and CA. So if we look at those two chords, we can see that CN, which is 12.5 minus X, multiplied by NA, which is 12.5 plus X, I'll just write it over here. And this is equal to dn times nb, and we know that dn is 280 over 39, and nb is going to be, looks like 500 over 39. And now we can just solve for x. We get 12.5 squared, because this is the difference of 2 squared. minus x squared is equal to 500 times 280 over 39 squared. And we can just, like, I guess just solve for x now. So multiply. So x squared equals 25 over 2, because that's this part. 25 over 2 squared. Subtract 500 times 280 over 39 squared. I mean, in the actual competition, you could actually just evaluate this, but I'm just going to use a calculator right now, I guess. That's the oh crap. Okay. Well, anyway, I think this should evaluate to 625. Well, after you take the square root of this side. So that means x is that. So you should get this answer after simplification, and obviously in the real competition, no calculators are allowed, so you should just simplify this, and it's not that hard. It's just calculation. But yeah, that's like my solution to this problem. There's probably obviously gonna be a lot maybe cleaner solutions that I haven't seen, but this is just the problem. This is just the solution that I used when I mocked. So yeah, thank you. I hope you enjoyed this solution, and if you would consider subscribing to my channel. Thank you.